This paper was published in Nature Geoscience. It explores topics such as rain-driven mixing, wet deposition, air-sea CO2 exchange, tropical heavy rain, and ocean carbon uptake. Let's first hear a simple explanation.
Does rain help the ocean soak up more carbon? Air has a gas called carbon dioxide, CO2, that comes from things like cars, factories, and breathing. The ocean acts like a giant sponge for some of that CO2, taking it from the air into the water. Gas moves between air and sea a bit like sugar dissolving into tea. If the water is stirred or if the surface is different, the sugar, or CO2, dissolves faster or slower. Rain can change the very top layer of the ocean by stirring it, making the water less salty, and by bringing stuff down with the drops. These simple ideas help explain how rain might change how much CO2 the ocean takes in. Scientists used satellite and ocean data from 2008 to 2018 to check how rain changes the ocean's carbon uptake. They found rain makes the ocean take in an extra 0.14 to 0.19 petagrams of carbon each year. That's about 140 to 190 million tons. That is about 5 to 7% more than the ocean would absorb without rain. Two things matter roughly the same amount. 1. Rain stirs and changes the top layer, so more CO2 moves in. This is strongest in the rainy tropics. And 2. Raindrops carry CO2 and drop it straight into the sea, important in the tropics, storm paths, and the Southern Ocean. This matters because the ocean's extra help in taking up CO2 slows how fast Earth warms. Knowing rain's role makes our estimates of the carbon cycle more accurate, like fixing a scale so it gives the right weight. It also means if rain patterns change with climate, the ocean's ability to soak up CO2 could change too. Better knowledge helps scientists and leaders make smarter plans to protect the planet.
Ready for the next level? Here comes the science explained with real research terms.
Can rain help the ocean absorb more carbon dioxide? The ocean and the air exchange carbon dioxide, CO2, at the surface. Think of the ocean surface like the top of a swimming pool where gas can move in and out. Two main things control this exchange: how fast the water mixes, like stirring a drink, and the difference in CO2 concentration between the air and the surface water, like how a smell spreads from a perfume bottle into a room. Rain changes both. Falling drops stir and mix the top layer of the ocean, increasing turbulence, and the fresh rainwater can dilute the salty surface, changing how much CO2 the water can hold. Rain can also carry dissolved CO2 from the air into the ocean when drops fall, a bit like delivery trucks dropping packages into a warehouse. This is called wet deposition. Scientists use satellites, ocean instruments, and weather data to measure these effects over many years. Using global observations and models from 2008 to 2018, the study found that rain increases the ocean's uptake of carbon by about 0.14 to 0.19 petagrams of carbon per year. That's roughly 140 to 190 million metric tons. This boost is about 5 to 7% of the ocean's total annual carbon uptake, approximately 2.66 pgc per year. Two rain-related effects are both important: rain-driven mixing at the air-sea interface, and CO2 added directly by falling raindrops. The mixing effect is strongest in the tropics, where heavy rain and light winds dilute surface water and let the ocean take up more CO2, while wet deposition matters a lot in tropical storms, storm track regions, and the Southern Ocean. Knowing that rain measurably increases how much CO2 the ocean absorbs helps make climate models more accurate. If we ignore rainfall, we underestimate the ocean's role as a carbon sink. That matters for predicting future climate change and for designing policies to reduce greenhouse gases. Also, because the effect varies by region, especially in the tropics and Southern Ocean, it highlights places where small changes in rain or wind could change how much carbon the ocean removes from the atmosphere.
That's it for today's paper. Thanks for tuning in. See you next time.